We now discuss the solution of a problem from the section Sets, Relations and Functions. The problem is based on the concept of equivalence relations from the subsection Relations. This question has appeared in the joint entrance examination main held on 28th June 2022 in the second shift. The given question is, let R1 is equal to the set of ordered pairs A comma B belongs to n cross n, where modulus of A minus B less than or equal to 13, and R2 is the set of ordered pairs A comma B belongs to n cross n, where mod of A minus B is not equal to 13, where n is the set of natural numbers. Then on n we are given four options. Option A, both R1 and R2 are equivalence relations. Option B, neither R1 nor R2 is an equivalence relation. Option C, R1 is an equivalence relation but R2 is not. And option D, R2 is an equivalence relation but R1 is not. So we are given this capital N is the set of natural numbers, and we are given two relations, and the relation R1 and the relation R2. So required to discuss the nature of these relations, whether both are equivalence relations or whatever it is. That means we have to decide the equivalence relation nature of R1 and R2. Let's now discuss the solution of the problem in detail. We are given capital N is the set of natural numbers and R1 is the set of all ordered pairs A comma B belongs to n cross n. All those ordered pairs A comma B belongs to n cross n such that mod of A minus B less than or equal to 13. To show that R1 is an equivalence relation, we have to discuss their nature of reflexivity, symmetry and transitivity. If the relation R1 satisfies all these three properties, then R1 will be an equivalence relation. First, let's go for the reflexive relation. So for each A belongs to n, we have mod of A minus A is equal to 0, definitely less than or equal to 13, and this will tell you A comma A belongs to R1 for all A belongs to n. That means R1 is reflexive. Second property, we go for symmetry. Ordered pair A comma B belongs to R1 implies by definition modulus of A minus B less than or equal to 13, and mod of A minus B is equal to mod of B minus A for all A B belongs to natural numbers. So this will imply B comma A also belongs to R1. So this will tell you R1 is a symmetric relation. The third property, transitivity. Now note that mod of 1 minus 2, mod of 1 minus 2 is 1 less than or equal to 13, yes. Mod of 2 minus 15, 2 minus 15 is 13, yes, equal to 13, it's okay. Mod of 2 minus 15 is less than or equal to 13. That means 1 comma 2 belongs to R1 and 2 comma 15 belongs to R1, but 1 comma 15 does not belong to R1. Why? Because mod of 1 minus 15 is 14, which is greater than 3, which violates the condition. So therefore the transitivity is not satisfied. So R1 is not transitive. Thus R1 is not an equivalence relation. Let's go for the discussion of the relation R2 in the next slide. We have R2 is the set of all those ordered pairs A comma B belongs to n cross n, such that mod of A minus B not equal to 13. Not equal to 13. First, we go for reflexivity. For each A belongs to N, mod of A minus A is 0, which is not equal to 13. Therefore, A comma A belongs to R2 for all A belongs to N. Therefore, R2 is reflexive. Second, A comma B belongs to R2 implies mod of A minus B not equal to 13. And whenever A, B are natural numbers, mod of A minus B is equal to mod of B minus A. That will imply mod of B minus A is not equal to 13. This will imply B comma A also belongs to R2. Therefore, R2 is symmetric. Let's get into the transitivity. Note that mod of 1 minus 2 is not equal to 13. Correct. And mod of 2 minus 14, that is 12, not equal to 13. Correct. That means 1 comma 2 belongs to R2 and 2 comma 14 also belongs to R2. But the 1 comma 14 does not belong to R2. Why? Because mod of 1 minus 14, that is 13. Mod of 1 minus 14 is 13. But the condition is not equal to 13 you should get. But it is equal to 13. That means it violates the condition. Therefore, R2 is not transitive. So thus R2 is not an equivalence relation. Is not an equivalence relation because the transitivity is failed here. So our conclusion is neither R1 nor R2 is an equivalence relation. And let's look at our options. Our answer, neither R1 nor R2 appears against option B. Therefore, the answer to this question is option B. So that is the detailed discussion of the solution of the problem from the unit 1. And the question is based on the concept of equivalence relation. And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.